Hi, I'm Fergus Kelly, and for my project I'll be creating a car telemetry system. I'm taking on this project as a solo endeavor, and in this project update video, I hope to explain to you exactly what I'm doing and how I'll accomplish it. So, what is telemetry? Here's one good definition, but generally speaking, I tend to think of it as gathering data from sensors and storing or transmitting it for display and analysis. It's used in medicine, transportation, agriculture, and spaceflight. But where did my interest in telemetry come from? Well, in Formula One and nearly every other kind of motor racing, telemetry is essential for maximizing performance of both the car and the driver. It's even become a political issue within the sport, where some drivers want to keep their telemetry secret from their teammates in order to maintain a perceived advantage. Graham Hackland, the Chief Information Officer of Williams Martini Racing, describes the type and scale of the data they are tracking. However, this type of technology isn't just used for multi-million-dollar racing machines. Take, for instance, my humble 2005 Toyota Prius with 180,000 miles on it. Although it isn't as fast as a Formula One car, it does have a number of sensors and electronic control units that generate a significant quantity of data. By law, every new car sold in the United States must have a standardized electronic interface for retrieving data, called Onboard Diagnostics 2. You've probably seen this used when you have your car's emissions tested, or if a mechanic has used a scan tool to figure out why your check engine light is on. The OBD2 standards specify a 16-pin connector, usually located under the dashboard, and a series of protocols and binary message formats for exchanging data. Types of data available through OBD2 include speed, engine RPM, accelerator pedal position, oil and coolant temperatures, and fuel rate. In addition to the OBD2 standards, many cars, including my Prius, implement the Controller Area Network Bus standards. Each electronic control unit on the car communicates with the others using the CAN bus, so nearly all data produced by the car is available on that bus via the OBD2 connector. Although the CAN standard specifies the physical architecture and protocol for communicating on the CAN bus, each car manufacturer has a proprietary message format which can make retrieving the data difficult. So, for my project, I'm creating a telemetry system to collect and display data produced when I'm operating my car. This is the equipment I'll be using. In addition to the equipment pictured here, I'll also be using a soldering iron for assembly, as well as a Ubuntu Linux laptop and a Windows 7 desktop for development and debugging. Here's the big picture of how the system fits together. The OBD2 UART communicates with the car's CAN bus via the OBD2 connector located under the dashboard. The FTDI board allows software running on the Raspberry Pi to communicate with the UART through a serial connection. Altogether, this creates a system whereby software running on the Raspberry Pi can freely fetch data from the CAN bus. For the software side, I will write two programs to provide telemetry functions. Both will run on the Raspberry Pi. I've already completed Milestone 1. I've purchased the equipment and prepared the Raspberry Pi while I waited for the other equipment to arrive. Milestone 2 involves assembling all the hardware into a functional system. For Milestone 3, I will check that all the pieces of the system work together and return proper values. Milestone 4 will be developing the telemetry logging software. Milestone 5, time permitting, will be developing the real-time telemetry display software. Finally, Milestone 6 will involve automating the logging process and building an enclosure for the hardware. The rest of the semester will be spent filming and editing the final project video, as well as creating the final documentation and schematics. I hope you find this project as exciting and interesting as I do. Here are the references I couldn't fit in earlier. Thanks for watching my video.